Morning, welcome back to Algebra 1 Semester 2 Summer School. Today's learning objective is to be able to simplify and convert radical expressions and rational exponents. Couple of terminology pieces. Radical means root, so this is where you're going to see square roots, cubed roots, etc. And rational means fraction. So those are going to be the terms that you're going to see as we're working our way through this. So we can use fractional exponents to represent powers of numbers or variables. When we have this fractional exponent, the numerator or the top of our fraction represents the power we're raising the number or the variable to. The denominator of the fraction is the root of the number that we're trying to take. The exponent in the denominator must always be positive. So if we're doing a negative exponent, we're going to treat that as the positive, as the numerator. Good grief, is the negative value. So let's look at a couple of different examples here. So for example A, the 1 is our power, and the 2 is the root, and x is the base. So we would write x under a root. We're talking about the square root, so the 2 goes on top, and the 1 power is what we're going to take our variable to. Now, typically when we write a square root, we do not include the 2, we do not include the 1 power. So the best way to write this would be the square root of x. For part B, sorry, my dog's growling, you'll just have to ignore it. For part B, same idea. The top number is our power, and the bottom number is the root, and 9 is the base. So we would start with 9. We're going to raise 9 to the first power, and then we're going to take the square root of 9. Now, 9 is the number 3 times 3. And since it is a square number, when we take the square root of a square number, we just get the number itself. So the square root of 9 would be 3. Sort of what happens is anytime you've got 2 factors inside of the root and you're taking the square root, one of them gets to come out. Let's look at example C. The 2 is our power, and the 3 is the root. X is the base. We're going to raise it to the second power, and then we're going to take the third root. And that would be in simplified form. For your independent practice, I would like for you to try A and B. C and D are going backwards. So I'll go ahead and give you example C so you can kind of see what that looks like. Okay, again, the 3 is our root, the 2 is our power, and Z is the base. The power goes on top, the root goes on bottom. So this would be Z to the 2/3 power. So for independent practice, I'm going to have you do A, B, and D. You can either pause the video now and try those 3, or you can come back and do them at the end after you finish the notes. Your choice about how best to do that. All right, to simplify the square root of a number, one way to do this is to create a factor tree, and any 2 identical numbers may come out of the radical. It's a buddy system. Okay, so here's what I mean by a factor tree. We're going to take 48 and we're going to factor that number into a smaller product. So I notice 48 is an even number, so I know it's divisible by 2. 2 times 24 is 48. Now, 2 is a prime number, so we're going to leave 2 alone, and we're going to factor 24. 24 is still an even number, so we're going to factor out a 2. 2 times 24 is 12. 12 is an even number, So we can factor out a 2. 2 times 6 is 12. 6 is an even number, so we can factor that out to 2 times 3. 2 is a prime number, 3 is a prime number. This allows us to write 48 as a product of prime numbers. So I have 1, 2, 3, 4 2's, 1, 2, 3, 4, and a 3. All right, now that we have our prime factors, we want to look for partners. Anytime you have that buddy system, so pairs of numbers that match. So there's a pair of 2's, there is a pair of 2's. 2 buddies get to come outside of the radical. So the first pair of 2's becomes a 2 outside. The second pair of 2's becomes a 2 outside. And if it doesn't have a buddy, it has to stay inside of the root. Then we can multiply anything together that's in front. So we have a 2 times a 2. That gives us 4 square roots of 3. So this would be the simplified square root for the square root of 48. Okay, let me try one more with you as an example, and then I'll leave you the other 2 to try on your own. I'm going to do the square root of 32. So 32 is an even number, so we have a prime number 2 times 16. 16 is an even number. 16 is 2 times 8. 8 is an even number. 2 times 4. And 4 is an even number. 2 times 2. So inside of my root, we have 1, 2, 3, 4, 5 2's. So 1, 2, 3, 4, 5 2's. Anytime you have a pair of numbers, those pairs get to come out as a singleton. So a 2 gets to come out, a 2 gets to come out, and the single 2 by itself has to stay inside. Then anything outside we can multiply. 2 times 2 is 4. Anything inside we can multiply, and we have a 2. If there were more than one number inside, let's say we had a 2 and a 3 left inside, we could multiply anything inside together as well. All right, your independent practice for square roots is 8 and 18. You can pause the video now and try them, or you can come back and do it after we look at the bigger roots. Okay, simplifying cube roots uses the same process, except now 3 of the same numbers are needed to come out. The same is true for any other power outside the radical. Whatever that power is outside the radical, that's how many parts we have to have matching to come out of the root. So I'm going to do the middle one as an example on this page. So this is the cubed root of 32x to the 4th, y to the 5th. So we want to multiply that 32, or factor out the 32. Now, if you remember, I just did that right up here, so we don't have to do it again if we've already done it. So I know that we have the cubed root of 5 2's, and then I have 4 x's. That's what x to the 4th means, is I have 4 x's, and I have 5 y's. So remember, exponents mean repeated multiplication. Now we want to look for groups of 3. So here's a group of 3 2's, here's a group of 3 x's, here's a group of 3 y's. So the groups get to come out in front. So I get a group of 2 out in front, a group of x out in front, a group of y out in front. And then inside the root, anything that doesn't have a group of 3 has to stay in. So I have a 2 times a 2 times an x times a y times a y. Now we get to simplify and make it look nice and pretty. So outside we get 2 times x times y, which is 2xy. And then we have the third root of 2 times 2 is 4 times x. Y times y is y squared. So this would be the simplified form of that. Okay, let's take a look at doing this fourth root at the bottom of x to the 11th. So x to the 11th means that I have 11 x's. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 x's. And we want groups of 4. So that's the first group of 4, that's the second group of 4, and I don't have 4 left. So I get 2 groups of 4, or 2 groups of x that get to come out. So 1 group of x, 2 groups of x, and then inside I have 3 x's left. So we would write this as x squared times the fourth root of x cubed. Okay, that should give you enough to finish this page. When you're done, come on back and we'll start looking at the next page. All right, we're going to do a couple of examples now to evaluate the exponential. So now not only are we going to take the root, we're actually going to do some evaluating and figure out what the value is of this expression. So kind of we're bringing it all together at this point. So if you remember, the top is a power and the bottom is a root. I find that most of the time it is easier to work with the root first and then look at the power. So I like to separate this and think about this as 25 to the 1/2 power to the third power. So we're going to separate the root and the power. You could write this as the square root of 25 to the third. That's that same idea. And maybe that's less confusing. So we're just going to write this as the square root of 25 to the third power. Now, we're going to evaluate the root like we were doing. So 25 is 5 times 5. So we have a pair of 5s. So the square root of 25 is 5. And now we want to take 5 to the third power, which is 5 times 5 times 5, which is 125. Okay, I'm going to give you one more example and then I'll leave you a few to try on your own. E's got a lot going on. The first thing I notice about E is that it has a negative exponent. Negative exponents mean we want to flip the base. So to deal with that negative, I'm going to take 64 over 25 and flip it and do 25 over 64. That's going to give us the positive 3/2 power. Notice the exponent doesn't flip, it's just the base that flips. Now, 3 is our power, 2 is our root. So I want the square root of 25 over the square root of 64. And we're going to take that to the third power. The square root of 25 is 5. The square root of 64 is 8 to the third power, which gives us 5 times 5 times 5 over 8 times 8 times 8, which is 125 over 512. Okay, B, C, and D are some examples for you to try, and then we're going to look through some more examples. So you can pause and finish up those 3, then we'll come back and finish out this page. Okay, if the radical contains a root or a variable, what we can do is we can do a little bit of reducing, and I almost think it's easier to do this in turning it into a fraction. So this would be x to the 10 over 2 power. Now, the fraction 10 over 2 reduces to 5 over 1. So that means 5 is going to be our power and 1 is our root. And we don't really have to worry about a root of 1, it's just the number itself. So this simplifies to x to the 5th power. So that's one way you could go about doing this. A different approach is to write it out like we were doing before. So we have 10 x's and we want to look at how many pairs we have. There's 1 pair, 2 pair, 3 pair, 4 pair, 5 pair. So we have 5 pairs of x's that come out and nothing's left inside the root. So we would get x to the 5th. I don't care which approach you take. That's totally up to you. But we do want to make sure that you can get to the correct answer efficiently. Okay, let's look at example C. Now, don't let that expression scare you because all of this is inside of the parentheses. So we're not even going to touch it. We're just going to leave it alone and pretend it's like our x. So 24 is our power, 3 is our root. So if we write our exponent would be 24 over 3. 24 is divisible by 3, it is 8. So that would be the power that we want to take our base to. So in our base is 4x plus 7. It's just a complicated base, but that's what our answer would be. Okay. All right, one more to try and look at. We want to take the 5th root of 243, x to the 10th, y to the 20th. Now, 243 is not an even number, but it is divisible by 3. It is 3 times 81. 81 is 3 times 27. 27 is 3 times 9, and 9 is 3 times 3. So we have 1, 2, 3, 4, 5 3's. So another way that we could write this is 3 to the 5th power, x to the 10th power, y to the 20th power. Now notice we have 3 different powers, but they all have the same root. So we can use this idea. So the base of the 3 would be 5 over 5. So remember, this is our root, so that's at the bottom of our fraction. X has 10 over 5, and y is 20 over 5. Then we want to reduce those exponents. 5 over 5 is 1, 10 over 5 is 2, 20 over 5 is 4. And we usually don't write the first exponent, so this would be 3x squared y to the 4th. All right, I'm leaving you 3 to try here, B, E, and F. And we're going to skip the bottom of page 60. You don't have to worry about those 6 examples on the bottom. They're just getting more complicated, and we're not going to go there. That's the big ideas for today. Please make sure that you are doing the independent practice and uploading those pictures in the form. Make sure you get things submitted. Good luck on the formative assessment. And please let me know if you have any questions. I'm happy to help. Thank you. Have a good day.